Sometimes I get an elevator and people start to me.
Yes, sir.
Okay, we're back. Okay, let me tell you the other common sense notion. We talked about, here's the other common sense notion to which about 80% of the people subscribed. Negro soldiers will perform better with white sergeants than with Negro sergeants because they're used to taking orders from white people but not used to taking orders from other Negroes. About 80% of people believe that's true, even people that, didn't have any particular prejudices one way or the other. People believe that was true. Now today it sounds ridiculous to us. Of course they went and they tested it, right? And they checked it out. And it turned out the overwhelming majority of black soldiers did a fine job. It didn't matter what their sergeants looked like. And once again, and the very small percentage who screwed up, again, it didn't matter what their sergeants looked like. Okay? People believe things. It's common sense. It makes sense. And common sense notions, right, are often it's the job of science to break through common sense notions. Okay? I'll give you an example. Okay, everybody stop. Okay, stop. If you're on the tape, stop. Close your eyes. Do you feel yourselves hurtling around in a circle? Do you feel yourself spinning? Use your common sense. We're not moving. You can't feel it. Use your common sense. Look in the sky. You can see the sun moving. No, wrong. All of a sudden we're told by scientists, not true, we're going around the sun and we're spinning around while we're doing it. And even though it looks like the sun is moving, we're the ones who are moving. Now we get a little sense that you ever have a car back up next to you and you jam on your brakes because you think you're going forward. Okay, that's what they tell you. But you have to be careful about this. You have to be very, very careful because what makes sense to one person doesn't, okay. So let's go back to the PowerPoint. Okay, see if we get my picture up in the right-hand corner there. What constitutes common sense is always changing, right? We're always changing. And the worst part of it is, people often tell you to use your common sense when they want to make it seem that their prejudice is the only conclusions a reasonable person can reach. Well, how do you know that? Use your common sense! Which means, what are you, an idiot? Common sense doesn't work. I need evidence. And what seems so obvious, okay, and often experts fall into this trap, right? I'll give you an example. I'll give you an example. Come back to me if you can. Osteoarthritis. That's the one that's the disease, right? Rather than the wear one. Rheumatoid arthritis is the wearing down. Osteoarthritis comes from the deposit of calcium in your joints. And the joints get caked with calcium and you can't move them, right? Use your common sense. Isn't it obvious that if you have that situation, you should completely cut out any calcium in your diet? It's common sense. Don't drink milk, don't eat cheese, don't eat this, don't eat that. Are you a health major?
Dietitian.
She's a dietitian. Go ahead, tell us. What? No. What is the connection between how much calcium you eat and arthritis?
There's none.
None. None. It's common sense that if you have too much calcium, you should not eat it, but there's none. It has to do with, what does it have to do with, do you know? I don't know. She's not an MD. What do I tell her? Right? By the way, the same thing is almost true. Now she's going to get mad at me. We have a dietitian here. It's almost true with cholesterol. If your cholesterol is 230, you can go on a diet and maybe get it down to 190 or 210. If your cholesterol is 400 or 350, diet's not going to do it. Diet is only a very small. My father-in-law, may he rest in peace, as they say, the guy was an egg fanatic. Right? If he got through a day without eating a dozen eggs, right, it was because he bumped his head and was unconscious for a while. Eggs, 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 eggs. His cholesterol was in the 170s, right? Many of these processes, it makes common sense. Well, with diet it's a little bit, but mostly, It's other body functions that are independent of what you eat. Use your common sense. Or for instance, right, there was another one. A lot of vegetarians claim that what you eat, it's common sense that if you don't eat the meat of other animals, right, it just seems to make sense. You'll be more passive, more, right? And there were a lot of vegetarians who claim that it's just common sense. If you don't go out and don't do what hunting animals do, which is aggression and eat, if you don't eat that stuff, you'll be calmer, right? The first talk show format was a guy named David Susskind, David something or other. David Susskind, he had this talk show, and some vegetarian got on there, and Susskind goes over, he says, you know, Hitler was a vegetarian. He was pretty aggressive. And so was one of the leading generals in the Japanese army. And I mean, it may be common sense, but the evidence, I mean, of course, that's just one thing, but evidence shows, matter of fact, evidence shows that what you eat, unless it's a drug, doesn't have much effect on your personality at all. We're going to get to that in a second. So you have to be careful about common sense. And you have to be careful, particularly about people making you feel like a damn fool by saying, well, you must be wrong, because anybody with common sense would agree with me. So, okay, let me see if I have my link back here. All my link backs have stopped working. Okay, the next one, let's go here, is common knowledge. What everyone knows. Okay, come back to me for a second. Before we do this, I have to talk about an experiment that'll mean this. How many people are aware of the fact that imbibing sugar, eating sugar, makes people more hyper? Who's aware of that fact? Raise your hand if you're aware of that. Raise your hand! None of this stuff, okay? The vast majority of people. Come back to me. Not true. Everybody knows it. Teachers know it, this person knows it, that person knows it. The only time it's not true is when you do controlled scientific experiments. And you give half the kids sugar, and you have half the kids food without sugar. It might be a candy, a sugared candy, and the same candy with, and you have people observe them who are neutral, right? People who don't know who had what. It's called blind. I'm blind. I don't know who had what. Never a difference. One time, there was an experiment, there was a difference. The kids who had the sugar were actually calmer. But it probably had to do with the sample, because when you repeat it and repeat it and repeat it, it doesn't make a difference. You shocked? Here's our nutritionist. She was going like this the whole time. Go ahead. You want to make a comment? Go ahead.
Well, it's actually the opposite. So, like, if you eat a plate of pasta, you're tired afterwards.
Right. Actually,
right. Makes you good.
We all know if we eat a lot, right? But if you have one kid eating a piece of, now of course what happens is that kids tend to go hyper when they're eating sugar, like they're sitting there all day in class and then it's lunchtime and they're eating their candy, or it's a birthday party and they can run around and they're eating a cake, but they run around whether they do or not. Yeah. By the way, eating things that produce a lot of sugar, like high, starches, right? You had a bowl of spaghetti and right? My wife already knows this. I eat supper, I'm supposed to clean the table. Tell her I can't move, right? Just wait a little while. I'll do it eventually. She's learned to believe me, okay? Unless I fall asleep. Anybody ever do that? You fall asleep and 3 o'clock in the morning, you're up there clearing the table? I'll raise my hand, okay? In any case, let's go to Colin. Let's go back to the PowerPoint. Let me emphasize again that there's no evidence that anything you eat has any effect on your personality, unless it's a drug, of course. Okay, like drink 17 cups of coffee with caffeine in it, it might have an effect on your personality. Okay, the general acceptance of an idea is not evidence. The fact that almost everyone accepts something as being true does not mean that it is true. Okay, 50 million Frenchmen can be wrong. There used to be a statement, 50 million Frenchmen can't be wrong, which means if everybody agrees, who are you to say it's not true? Everybody knows the world is flat. Who are you to say it's round? Everybody knows that. Everybody knows that the farther south you go, the hotter it gets, and if you go farther south than this, you'll burn up. Well, until somebody said, in Europe, said, I'm going to keep going farther south and begin to get cooler. What do you know? All right. Okay? Let's go back to the PowerPoint. This may be the worst mistake they can make because it's virtually impossible to prove that something is not true. Okay? That's the problem. Okay? Come back to me now, and I'm going to show you what I'm talking about. Look, let me give you a little hint here. All this psychology you're studying, all this stuff about people, all this methodology, forget it. It's all garbage. Let me tell you what determines what people think and feel. There is a giant, enormous green grasshopper, I'll make it easy, somewhere in the solar system, jumping on this giant keyboard at near the speed of light, typing out whatever is going to happen to people, what you're going to think and feel and do. Okay? I have evidence for it. How many times do you go and all of a sudden it's like you blanked out for 30 seconds? Right? You say, what happened? You know what I'm talking about? That's because the grasshopper was a little behind on you. How many times did you look for something on the sink, it's not there, and you look again, it's right there in front of you, right? That's the grasshopper. You sort of blacked out, not catching up with what you're going to see. There's a grasshopper out there. That's what it is. Forget all the rest. This giant green grasshopper. And I believe this until you give me evidence that it's not true. Okay. So what are you going to do? You're going to prove to me that the grasshopper's not there. So what are you going to do? I could make it in the universe and really be nice, but let's just make it the solar system. What are you going to do? Let's make it, I'll make it easy for you. Somewhere within the, inside the orbit of Jupiter is this grasshopper. Somewhere. So what do you got to do? Go ahead.
Well, we can look everywhere inside of the orbit of Jupiter and not find the grasshopper.
Right, you're going to have to. That's right. You're going to have to look everywhere inside the orbit of Jupiter, on every asteroid, on every moon, in every cave, under every ocean of every planet, Mercury, Venus, Earth, and Mars, and the asteroids. So you went and you go to the moon. Say, well, maybe the grasshopper's on the moon. You look and look and look. You go into every square inch of the moon, inside of every cave in the moon. It's not there. Well, I say, well, it's not on the moon. Maybe it's on the Earth. You look everywhere and everything. Keep looking, right? Could be there. When people accept something as being true, it's impossible. Now, I could really be rotten. Tell me your name.
Oscar.
What?
Oscar.
Oscar. See, really be Oscar and say, great thing on television, you can have a coughing fit, lose your voice. The grasshopper's mobile. Then you'd have to be everywhere.
At every time.
At the same time. But even without that stinky little thing, the grasshopper has a little rocket ship, you know. So I could, let's go back here to the PowerPoint. There we go. The true believer can always say, I know I'm right, keep looking. Keep looking, keep looking. I'll be right for hundreds of thousands of years until you look everywhere. Keep looking, keep looking, keep looking. We believe because everyone says something is so, even though there's no evidence to support this belief, because there's really no way to demonstrate something is not true. The believer can always resort to saying, keep looking for the evidence that he or she knows is there. A scientist will say to me, you could be right. That grasshopper may be there. But until you show me evidence that it is there, I'm going to have to function under the assumption that it's not. Scientists never say, I believe it, until you prove to me it's not true. What they say is, I don't believe it until you give me evidence that it is true. Yeah, go ahead. What you done?
Prove by contradiction, can you do that? Prove by contradiction, can we do that?
Yeah, go ahead. He's being a wise guy. He's bringing up something else. But go ahead. Give an example of proof by contradiction. Right.
assume it's not there, we try to prove it's there. And we will not find it as it's not there.
Right. But you have to assume, you can't assume anything is true without evidence. Okay? Now you can prove something by contradiction. For instance, if I tell you it's raining at this, I show you evidence, I take a satellite and you can see it's raining there someplace, and I can say, well, it's proof that it's not raining there. It's proof that it can't be not raining there, because there's a logical contradiction. But that's right. But it always has to be evidence. You cannot ask me to bring evidence that it's not so, because I can't prove something not so. I could always say, keep looking, keep looking, keep looking. You want to hear one? We know that kids who are labeled dyslexic have something neurologically wrong with them. That we know. Let's try this. I just got to get a little information about myself. You know that big lottery, the $100 million lottery, the Texas, I really won that. That lady who claimed she won, she was a front for me. I invested and tripled my money. I won the Irish sweepstakes before that. I have tens of billions in dollars. I make Bill Gates look like a pauper. So I have all the money I want. All the money. So what is he doing up there, right? Just for fun, right? I have all the money I want. And what I'm going to do is to give money to anything that's even vaguely, because I don't care, I have so much money, you know. I go into stores and I spend $1 million, I come out, I'm richer than I was before because it's all invested, I'm in great shape. Okay? That's even vaguely within the realm of trying to figure out what is wrong with children who have dyslexia. You got 57 different kinds of neurological projects, that's okay with me. You want to do something on home life? That's okay with me. Want to do something on vision? That's okay with me. Want to do something on hearing? That's okay with me. Want to do something on brain processing? That's okay with me. Whatever you want to do, I have the money. Did I do something wrong? Oh, water, thanks. Whatever you want to do. Is this to clean off the computer? I pour it on the computer? No, okay. Thank you very much. Oh, they brought it to me because I was coughing. Dead time. Thanks. Dan's knows about the water. He's always getting me water. Okay, that's the guy back there. Okay? How many people think that it's reasonable that this is okay science? This is a vote. You have to vote on the camera too. How many people think that this is a reasonable project? How many people think that it's stinkeroo? That or at least it has major flaws in it. How many think that I'm basically on the right track? How many people don't trust me already? This is only the first class and you don't trust me. Okay, how many people think that's basically okay? I'm going to give people to find out what's wrong with kids with dyslexia, whatever you want. Who thinks it's basically okay? Who thinks there's something wrong? Who thinks there's something wrong because of what I'm doing, but who knows what's wrong? It's bad. Bad, 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 bad science. Because what does it start out with? Bad premise. What? What's the premise? What should the question be? The question is, what is wrong with kids who have dyslexia? What is wrong with kids who have dyslexia that makes them unable to read? That's no good. What should the premise be? What should the question be?
Why can't kids read?
Why can't kids with dyslexia read? The first one, I start out with a conclusion. That there's something wrong with the kids. Right? I start with a pre-drawn conclusion. You're not allowed to do that. You can't start out with a pre-drawn conclusion. Every kid who can't read, there are no lousy teachers, there are no lousy curricula. There's no kid who was ever abused by, there are no curricula. Everything we do is, You have to ask, why can't the kid read? You can't start her with a conclusion. You have to ask why. Now, it's very self-serving to say, every kid who can't read, it's my fault. It's his fault. He's sick. Let's figure out what the signal. That's very nice, but that may not be true. You have to ask why can't the kid read? You cannot start out with pre-drawn conclusions. That's no good. You can't start assuming there's something wrong with a kid. Am I shaking people up? Just wait till we start discussing dyslexia directly. Okay, I'll give you a little hint. I think learning disabilities are the biggest scam foisted on the American public since P.T. Barnum retired. Okay, but we'll get to that. Don't worry, we'll get to that. It'll be all right. So you have to be very careful about assuming you know things are true. And when people say to you, well, children need structure. If you're a scientist, you say, well, what do you mean by that and how do you know? Children need freedom. Well, what do you mean by that and how do you know? This is the best way to do it. Well, how do you know? What are you talking about? Where's your evidence? And you should never assume anything without evidence, because once everybody knows something is true, it's very difficult to prove it's not true. Because people always say, well, keep looking. So when you take kids with dyslexia and they say, oh, they have some kind of neurological problem, do you have any evidence? No, but we know it's there. Keep looking. Head of the Orton Society said that neurologists know. How do they know? They know that there's something neurologically wrong, they just don't know what it is. They know, even though they have no evidence, they don't know. What are you talking about? I know that when people get angry, they lose their temper because of some gas in the air. I just don't know what the gas is. How do you know? If they can't find the gas, how do you know? They breathe too much of a mystery gas in the air. How do you know? I don't know, but I know it's true, so keep looking, keep looking, keep looking. That neurological problem is there. Keep looking, keep looking. I know it's true. As a matter of fact, you realize that when disabilities, if I can find out what's wrong, you're no longer disabled, it's other health impaired. If I find out keep looking, keep looking. We'll discuss that more later. That's why it's no good. I can always say, that grasshopper's there, keep looking. I know there's something wrong with the kid, keep looking. I know that this will work. Keep trying, keep trying, keep... No. You've got to give me evidence. And if you don't have any evidence, you may be right, but I can't assume that it's true. I have to entertain all the possibilities. You got it? Let me see if this link back works. So you have to be very, very careful. And as you can see from what I told, it doesn't work. I got to redo this program. And it's on here. Never mind. We'll just... Okay. So let's go back to the PowerPoint. The second kind of thing is, this is actually my kind of division. Most books on logic don't use this. It's something called unacceptable explanations. And I have to tell you, logic. You can have the best evidence in the world and screw it up with lousy logic. The use of proper logic is an integral part of the scientific method. If we make errors in logic, we can reach terrible conclusions even if we have good data. By the way, the word data is plural. Data are. A datum is, data are. Did you study Latin when you went to Catholic school? Oh, Lord. What has happened to the world? Okay. I went to public school and studied Latin. Anyway. That link works. Okay? So let's go back to the PowerPoint here. Here, I'll show you. See? And so good logic is part of, see, that link works. Okay. So we're going to talk about a couple of kinds of errors in logic. Okay? I'm going to basically talk about circular explanations. You often usually call it a circular definition, but I call it circular explanation because it's easier. Okay, you ready? Here's a circular explanation. A circular explanation involves saying the same thing in different words and pretending we have explained something. We do it all the time in education and, see if you can get my picture up there, in medicine too. Let me give you an example. See if you can get my picture in the corner. Okay, there we go. That man is losing his hair because he is balding. Now that's ridiculous, right? You all know that's silly. Balding means losing your hair. that woman is tired all the time because she has chronic fatigue syndrome. Chronic fatigue means tired all the time. You're tired all the time because you have tired all the time disease. Now, to be the most important thing to do, the most important thing to do when you're doing this is to use fancy words. Okay? Here, let's go to the overhead tablet. Does anybody know what this word means? Hirsute. Who said that? Bless you. Hirsute means hairy. Okay? If I said to you, that man is losing his hair because he has dishirsute syndrome, or hirsute deficiency syndrome, there's a good one. That sounds like something. Woo! I say balding, you laugh. But if I say hirsute deficiency, you go, oh, well, hirsute is not a noun. It's an adjective. Right? But you get the point. See, it's a guy with all his hair who knew that, right? What a hirsute, man. Good for you. You understand what I'm saying? You have to be careful. If I say, you're tired all the time because you have tired all the time, does everybody laugh? I say, chronic fatigue syndrome. Ooh. Now, to be fair to medicine, this is a throwaway one. Okay? This is a throwaway definition, and good doctors know it. It means I don't know why you're tired all the time. If somebody comes and says, I'm tired all the time, what do they check? What do they check to see why you're tired, right? Give me some of the stuff they would check. I had that. What? Go ahead.
Blood iron levels?
They check blood iron level, right? You have low iron deficiency, you can get tired. What else do they check? That's fine. So what else am I going to check?
Thyroid.
Check your thyroid? That's fine. What else might they check? Those are the two most common ones, yeah?
Diabetes.
Might check for diabetes. Check that. Blood sugar's fine. What else? They might check for a parasite, right? See if you have some sort of a parasite infection or something, low-grade parasite. Sometimes you can get infections and parasites eat me up like a tapeworm or something. You don't get a fever. Check that. That's fine. So I check this. I check this. I check this. I check this. I don't know. It's chronic fatigue syndrome, but it doesn't tell you anything, right? Check diet. How come you didn't say that we have a nutritionist? Are you certified? I'm writing to the board. I'm taking it away. Okay. Diet, right? People on who are protein deficient, I believe, are tired all the time. Isn't that right? Yeah, if you have a real protein deficient diet, you can be it can really get you down. Okay. By the way, that's one reason why kids who are in poverty neighborhoods and poverty often are very tired because they really have protein deficient diets. But, okay, it's less true today, but it still happens. Okay, so I studied with someone who grew up in real poverty in Puerto Rico. She was graduate students together, and she said, I just couldn't keep my eyes open half the time in class. Right? She said, finally, some teacher caught on and bring the kids little pieces of fish. And we both perked up, so you have to be careful. Okay, but you get that. It's a throwaway diagnosis. It really means I don't know. Let's go back to the PowerPoint. Okay? That person has trouble reading because she has reading troublia disease. Are you laughing? You laughing? Let's translate reading troublia into Latin. That person has trouble reading because he has dyslexia. This is the Latin translation of this. Are you still laughing? How come? It's just a silly. Oh, well, I have neurological problems. Really? You got any evidence? How many kids who are labeled with dyslexia have neurological tests? Almost none. We'll talk about that down the road. Let's go back here. That boy can't pay attention because he has can't pay attention disease. Now I don't even have to translate it into Latin. I just have to make it fancy English. Attention deficit disorder. Can't pay attention because you have attention deficit disorder. What is that? You're saying the same thing in different words, but circular explanations make us think that we've provided a real answer because they are always correct. It's true that a man who's losing his hair is balding. It's true that a person who's tired all the time has chronic fatigue syndrome. It's true that a person who has trouble reading has dyslexia because it means trouble reading. Right? Anybody shocked here about dyslexia? Did I shake anybody's belief system up? God, I hope so. Anybody want to fight with me? Do you want to argue with me? Argue. It's all right. Nobody's a special ed teacher? All right, ready? Okay. The problem with circular explanations is that they don't explain anything. They boil down to saying the same thing in different words and putting the word because between the two statements. That man is losing his hair because he's balding. That person is tired all the time because she has chronic fatigue syndrome. And come back to me. And the problem is, when you don't know what's wrong, you don't know what to do. And I'll give you a personal example. We have all kinds of words in medicine like that. Anybody ever go to a doctor and told you have a dermatitis? I have a rash on my skin. Oh, you have a dermatitis. I know I have a dermatitis. Dermatitis means rash on your skin. Anybody go to camp and you told you had conjunctivitis when you had pink eye? Conjunctivitis, that means something's wrong with your eye. Well, that tells me a lot. I go to a doctor. I have very sensitive skin. One of the things, I heard it from my father, that and sneezing in the sun. Okay, I got to tell you something. Sometimes my father would sneeze in the sun, I sneeze in the sun, and my son sneezes in the sun. I know this is dating it, but I have a new grandbaby, first one, I don't care. I go to visit him. He's 2 months old, right? I saw him when he was first 2 months old, 2.5 months old. We take him outside, he's in the sun, sneezed in the sun. I said, all right, family heritage, right? 4th generation sneezing in the sun. My grandfather may have sneezed in the sun, but I don't remember, right? But in any case, so I have this very sensitive skin. And I get rashes all the time. So I go to the doctor, and I have a rash that starts on my arm here, right? And it's itching and scratching. It's crawling all over the place. He says, oh, you have a dermatitis. Well, here, try this, try that. I try this medicine, try that medicine. Finally, I'm scratching. It's driving me insane. Finally, I said to him, these were the days we had to get referred to a specialist. In the plan we were on, I said, send me to a dermatologist. So I go to the dermatologist. I have this piles of medicine they were giving to me. So he looks at the medicine. He looks at the rash. He said, gee, he said, they really messed it up. He didn't quite say it that badly, but he said, it's very difficult because of the previous treatment. They screwed up. He said, but it looks to me, I had anti-yeast and antibacterial, antifungals. He said, it looks to me, from what I can tell, from what's, and cortisone creams, which had really made it, flare, do all kinds of, he said, it looks to me like it's an allergic reaction to something. He said, I don't know what it is. He said, I can find out eventually. He said, but usually if I treat it for any allergic reaction, it'll work. If it doesn't, we'll do microscope scrapings and find out exactly what it is. So he gives me a prescription for a topical antihistamine, and I said, that they didn't think right. See, he had a diagnosis. He knew what was wrong, so he knew what to do. I'll tell you how the story ends. After his, I had to go give a talk at the school. It's in the Presbyterian Church right across from the art museum. Anyway, I was giving a talk in that school there, so I don't know if they still have the school, but they did that. So I go in there, and I have the prescriptions. I pick them up, and I run to school. And before I go in to talk, I went into the restroom, and I took one of the pills, and I took off my coat and shirt, and I put the stuff on. Go there to talk. All of a sudden, 10 minutes into the talk, I realized, or maybe 20 minutes, there doesn't itch anymore. I couldn't believe it. So I drove home. I'm terribly sensitive to antihistamines. I'm driving all of my eyes over, right? He said, call me, and he said, call me the next day to tell me what happened. I called him up. I said, you made a miracle. And I told him the story, right? So he starts to laugh, because all he did was know what it was. He didn't say, oh, you have a dermatitis. He said, you have an allergic. So he said to me, wait a second, this all happened in the church, right? I said, yeah. He said, I'll tell you what. He said, I'll take credit for half the miracle, we'll give God the other half of credit, right? I mean, he's laughing at me. It wasn't a miracle. It was just stopping circular things. Oh, you have a skin rash because you have a dermatitis. Well, dermatitis means a skin rash. So you have to be very, very careful about circular stuff, right? This one doesn't work either. So we have And so what we get, of course, is this constant list. Oh, you're telling me you can't read because you have dyslexia. You can't write because you have, right? You have to be very, can't write, so you have this. You have to be very, well, let's discuss that more. You have dysgraphia. You can't do this. Take what a kid can't do. A kid can't blow his nose, he has dysblosia. Okay? You want to be fancy, take the word for blow your nose in Latin or Greek. Right? So you have to be very careful. The other thing you have to be very careful of, let's go back to the PowerPoint, is assuming causality from correlations. Okay? Oops, sorry. Correlation does not equal causality. Now, a correlation means that two things occur together in a consistent way or do not occur together in a consistent way. Okay? You understand? And those are called positive and negative. For instance, when it's night, it's never day. When it's day, it's never night. That's a perfect, or what's called a -1 correlation. Okay? There are correlations between other things. There are correlations between height and weight. Okay? If I take 50 people who weigh 200 pounds and 50 people who weigh 100 pounds, the average height of the first group will be more than the average height of the second group. Right? Now, almost certainly the tallest person in the, or if I take 1,000, the tallest person in the group that weighs 100 pounds, okay, let me say this. The tallest person in the group that weighs 100 pounds will probably be taller than the shortest person in the group that weighs 200 pounds, right? It's not a perfect correlation, okay, but it's there. Okay, understand what I'm saying? Height doesn't cause weight, and weight doesn't cause height. Okay? They both come from something else, right? Body structure, etc. Okay? Let's go back to the PowerPoint. The fact that two events or circumstances occur together does not necessarily mean that one causes the other. People who speak English are, on the average, wealthier than other people. Therefore, learning to speak English will make you rich. Right? If I took all the native speakers of English in the world, now there are poor people who speak English, rich people who don't. But on the average, if I took the people in Canada and the United States and took their average income, it's going to be higher than the average for the world. But one doesn't cause the other, right? Japanese immigrants to the USA eat more fats and have more heart disease than do Japanese immigrants who stay in Japan. Or eating fats causes heart disease. Wrong! It's speaking English. See if you get my picture up there, okay? Japanese immigrants who come to the United States speak more English than Japanese immigrants, so obviously it's talking English that causes you to have heart disease. Or maybe it's the stress of changing, moving, having to learn a new language, etc. But in the absence of corroborating evidence, one statement just makes just as much sense as the other. As a matter of fact, come back to me now for a second. As a matter of fact, it is true that Americans consume the most fats and have the highest rate of heart disease on the average. Japanese consume the least fats and have the lowest rate of heart disease. After that, it's pretty random. Norwegians consume a lot of fat, have much lower heart disease, rate of heart disease than Italians who consume less fat. With the exception of those two extremes, it's pretty random. There's an article in an Australian medical journal. They couldn't publish it in an American medical journal, but it's not so clear. Right? Once again, it's not so clear that the connection between the amount of fat you consume and the amount of fat that builds up in your arteries. Do you agree with that? As long as we're on this topic, I'm going to go back to another subject, what everybody knows. When I was in school, they had the 4 basic food groups. We're talking 45 years ago. And the nurse used to come in with her eyes shining would say, "You must eat from the 4 basic food groups or you will never be healthy." Now we're told to eat from 2 of them. You'll drop that on the spot from heart attacks. Red meats, and dairy products were two of the basic food groups. Right? Now people come in with their eyes shining and say, oh, you have to cut your dairy products, you have to cut your red meats, and everybody believes them. Well, we believed them. Really? By the way, you understand that that the fatter you get, the better it is, because as Americans since the 50s have been getting fatter and fatter, they've been living longer and longer. It's a correlation, right? See if you can figure out what the dirty trick is in that one. I'm not going to tell you. Am I right? It's true. The average lifespan today is much higher than it was in the 1950s. Fast food makes you healthy. We have been consuming more and more fast foods and living longer and longer. So, well, wait a minute. What about medicine? What about this? What about that? What about the other thing? Well, so that's why you can't assume causality from correlations. Just because two things come together doesn't mean one causes the other. Okay? Let's go back to the PowerPoint. And even if there is a causal relationship, we must be careful about assuming the direction of causality. Do clouds cause rain, or do rain cause clouds? Well, that's an easy one. Does good self-esteem cause high achievement, or does high achievement cause good self-esteem? Or does the third underlying factor cause both? Let me tell you something. That second one is a multi-million dollar question. When people began to do these kind of tests and found out that there was a big correlation between high self-esteem and achievement, and even in schools, poor neighborhoods, inner city neighborhoods, and other poor rural neighborhoods and other places where kids do poorly, the kids with the highest self-esteem had the highest achievement. Oh boy, they said, what we need is self-esteem raising exercises. Then the kids will achieve better. And so they went into the inner city, which had a lot of black kids, and began to do black pride kinds of stuff. Look at all the great black people there were. You should be proud to be black. Oh, I could write, look at all that. I don't know. Probably without even cracking a book. You can think of 50, 100, thousands and thousands of black people make contributions, right, in all areas, right? By the way, just for a minute, the man who has made the biggest change in American eating habits happened to be black. Who was that?
George Washington.
George Washington Carver. What did he invent? Peanut oil, but more important, peanut butter. To this day, I can't imagine what kids took to school before George Washington Carver. Peanut butter and jelly sandwich, right? This guy basically saved the economy of the South. When the boll weevil came, the South was decimated. And he said, grow peanuts. And then he figured out how to make oil from peanuts and peanut butter from peanuts and all kinds of stuff from peanuts, all kinds of peanut products out there that he did. It was probably America's greatest botanist, okay? Or at least he was. In modern times, now they got DNA and iron and who knows what they do. But, okay, and I don't know. I mean, you could just think of the guy who figured out blood typing was black. I can't remember his name. And I mean, he just goes on and on and on and on. You get a book, thousands of people. But I'm sitting here, I'm a little black kid in the 5th grade, and I have the name of 6 great black mathematicians. What does it have to do with the fact that I don't understand what's going on, right? So to tell me, or I'm sitting in English class and here are 6 great black literary giants, I don't know, I can think of probably 10 of them off the top of my head, right? What does that have to do? And if I did some research, I could probably get a few hundred of them. What does that have to do with the fact that, maybe it's the other way around. Maybe if I'm doing well in school, that's what makes me have good self-esteem. Or maybe it's the third thing. Maybe it's just a certain kinds of interactions in my home or in my peer group or something that causes me to both be able to achieve and makes me have good self-esteem. We don't know, right? This critique of feel-good curriculum, make kids feel good, oh, you're good, your ethnic group is wonderful, that critique has validity to it, right? Which is to say, how do you know which one's causing which one? Now, obviously, it's important for people to be proud of their ethnic heritage, especially if they feel there's something wrong with them if they're from a certain ethnic group. But that's not going to solve your basic problems. Okay? And by the way, we have some of that. We have some of that. Right? Okay. You assume me from a certain, well, if I'm black, I must be a great basketball player. And if I'm not, I must not be. So you have to be careful about that stuff. But we'll get to that later. But you have to be very careful about correlation and causality. And in general, this link doesn't work either. In general, you have to be careful, let's go back, about other kinds of, these are logical fallacies. A logical fallacy is an error in logic. Good data are not enough. You cannot have errors in logic. By the way, both, keep it on here, both circular explanations and assuming causality from correlations are logical fallacies, but you have to be careful of other ones too. You have to draw proper logic when drawing conclusions with evidence. And error in logic, even when we have trustworthy data, can often cause us to reach incorrect conclusions. And those are called logical fallacies. Let me give you an example of some logical fallacies. We'll be probably hitting some others we come to that, right? When it rains, all the sidewalks get wet. Very good data. I had a government grant, right? I took all the uncovered sidewalks in Houston and I put people around, thousands of people around, to examine what happens when it rains. They got wet. Oh boy, big stuff. I got a bigger grant, a bigger grant. Before you know it, I was examining all the sidewalks in Texas. Then all the sidewalks in America. Finally, I had a $100 billion grant from the government to examine all the sidewalks in the world. And every time it rained, a sidewalk got wet. Good data. If an uncovered sidewalk got wet. Well, I'm walking down the street one day, I see a wet sidewalk, I say, oh, must have rained. Really? Let's go back to the PowerPoint. What about the person washing her car? Right? I have good data and a lousy conclusion. If it rains and the sidewalks are wet, so if sidewalks are wet, it rains. Well, that makes sense. Right? If you drink cyanide, you die. So if you die, you must have drunk cyanide. Oh, really? If you have flu, if you have a flu infection, you have a fever. So if you have a fever, you must have a flu infection. Really? I don't think so. Okay. People who are damaged in certain areas of their brain lose the ability to read. These are good data run from soldiers who had closed head injuries in World War II. They found certain kinds of brain damage. So, if you have trouble learning how to read, you must have brain damage. Sound familiar? Really? Good experiments done at Clark University after World War II. Right, very interesting. It was the first real attempt to look at brain functioning, especially they had a lot of people with brain injuries, unfortunately, excuse me, a lot of the soldiers, so they got, so therefore, oh, you must have a brain injury. Of course, it's even worse because these were people who had normal brains and could read, and then they had damage and couldn't, versus people who were assuming, oh, if you can't read, I tried to teach you to read, you can't read, you must have an injured brain. Okay? Can you think of possible alternatives? Yeah, I don't even want to talk about it. We'll get there. The old program is, here's another one. The new program isn't perfect, therefore we should use the old program. This happens all the time. You get new ones and say, oh, look at the problems with it. Yeah, but what about the problems with what you were doing? I had a big fight with my cousin who was a math teacher. He says, oh, look at, they brought in this new program. So I said, you mean they brought it in because the other older one was perfect? That's why they decided to try a new one? Because they weren't having any problems with kids learning math with the old one? You have to look at both of them. There are all kinds. Have you examined it? Okay. And we're going to see other ones. There are a lot of errors in logic that people make. Okay. Let's see if this link works. No. Okay. Now I want to start something. I was supposed to finish today, but I won't. It doesn't matter. We'll get behind schedule. It doesn't matter. We'll get it all done in the end. Okay. I want to talk about data and theories because science has to talk about data and theory. Okay. Come back for a second. Who can tell me the difference? What are data? Data are. Data are what? For data are what? Well, you talked about it. Okay? Go ahead.
Measurements that are collected.
Yeah, it's observations that scientists make when they do their experiments. And theories? I'm doing the bang. There's nothing wrong with your tape. Theories? Data are the evidence of the observation, the facts gathered by scientists using the scientific method. Theories? Go ahead.
Theory's an idea.
How does it relate to data? You're darn tootin', that's exactly right, but how does it relate to data? Let's try this. We have time to do it. Ready? We're going to take another vote. I'm going to make a statement. You tell me whether the statement is a fact or whether it's a theory. We're living in a solar system. The sun is in the center and the Earth is going around it in an elliptical orbit. Who says that's a fact? Who says that it's a theory? 3 people say it's a theory. Okay, I'm going to prove to you it can't be true. That's a bunch of baloney. Okay, I'm going to need a sun. I'm going to be standing up. You're going to have some work for the camera person here. Who's wearing yellow? Close enough. You come be the sun. Okay. Who's wearing blue? The Earth's a big blue marble when it's seen from way out there. The sun and moon declare. Don't you remember Big Blue Marble? Here we go. You come be the Earth. I mean you to be a star. Oh no, you're going to be a star. You come up here anyway. Who's over 6 feet tall? How tall are you? 6'4". Come over here. He's giving me the business. Who's under 5'2"?
Would you like me to stand?
Stand over there. We'll be okay. Stand over next to this. Earth, come over here. Come on, who's under 5'2"? How tall are you? 5 how?
5'6".
Too tall. Who's under 5? Who's shorter than 5'6"? 5'3". You're 5'3"? Take your shoes off. She's got 5-inch heels on here.
You want me to really take it off?
Yeah, take them off. Okay, ready? Oh, we're in good shape here. Okay, go stand over there. Okay, sun, come over here. Okay, I'm going to build a little solar system here. Here's the Earth. Okay, stand over here. You stand over here. Face that way. You stand over here. Come over here. Move over just a little bit this way. Okay, ready? Okay, here's the Earth. These are 3 stars. This is the sun and this is the Earth. I'm going to prove to you by having the Earth do what you say the Earth does. Sun, don't move. That the Earth cannot be moving. Move over a little bit this way. No, not you. You stay with it. Move over this way. Okay, the Earth is going to start over here. Earth, start over here. In here, he's in his orbit. Okay, look at the stars. How many stars do you see? Now, this is only in 2 dimensions, so still, how many stars do you see?
3.
3. Which one's in the middle? The one with this one, okay? Start moving, start moving, start moving. Around the sun, start moving, stop! How many stars do you see?
Only 2.
2! Now remember, the sky, the positions of the stars in the sky, this is evidence. And the number of stars in the sky always stays the same. Stars don't jump around. Stars don't appear and disappear. They always say, you may get when you can see in the summer, you can't see in the winter, because you see in the winter, you can't see in the summer because of the tilt of the Earth. But basically, that's it. All of a sudden, the star disappeared 3 months later. Keep moving, keep moving, keep moving. Around this, around this. Okay, around this. Okay, take a look. How many stars do you see?
3.
3! Which one's in the middle? That one. So that star started out on the right of this star, then disappeared and popped up again on the left of this star because he's moving around. Okay? That never happens. Matter of fact, from the point of view of the Earth, this star seems to be going like this, right? Because if he keeps moving again, it seems to be going over, right? He keeps moving around there, seems to be moving up and back. That's called a parallax effect. Where you're standing determines what you see. There is no parallax effect on the stars. They're always in the same spot. When you move, you get a parallax effect. If I stand here, these 2 people are lined up. If I stand here, she's to the right of her. If I stand here, she's to the left. Right? There's no parallax effect on the stars. That is proof positive that the Earth cannot be moving. Who teaches science? Unless you can tell me what's wrong with this model, you got to go back and tell your students the Earth's not moving. It's not. How can it be? You saw what happened. What's wrong with this model? You have to tell me. What? Wait. What's wrong with this model?
There's more facts to be
established, or that need to be established. We're in a galaxy that moves in a spiral.
Okay. He said the galaxy moves. Okay. If I take this building and say this is the galaxy and start spinning this building around, and he does that, it won't change this at all. Won't change that at all. What's wrong with this model?
Too simplistic.
Look, it is simplistic, but what's the flaw? Look, the truth is the fact that no one has ever observed the Earth going around the sun. You'd have to see that for it to be a fact, for it to be evidence. No one's ever gone outside the solar system and taken a look. We're sitting here in the middle of it, looking at all these things in the sky. Some stars moving, that's what planet means, a moving star. Some not. We're looking at the sun appear to go through the sky, the moon and all this stuff, and we make a model to explain what we see. It's a theory! A theory is a model that explains data. What's wrong with this model? What's wrong with this model? What's wrong? If you can't tell me what's wrong with this model, then you're going to have to say the model that I have to explain what's going on with the seasons and with day and night. And of course, show me how you're really going around. You have to explain day and night like that, right? Stop. You have to stop just before you throw up, okay? What's going on here? What's wrong with this model? Does anybody know?
The scale's wrong.
Say it, what?
The scale is wrong.
The scale is wrong. If we assume, come over, stand over here, if we assume that this is the distance between the Earth and the Sun, okay, 93 million miles, where do these, let's say you're the nearest star, where do you have to be standing to keep this in scale?
I'm somewhere over in the parking lot out there.
In the parking lot? No, in the parking lot?
In the parking lot.
Rhode Island.
Now, keep on going north.
Boston? Boston, north. I want, somebody told me, you have to get off at Park Avenue. I'm looking for P-O-C-K Avenue, Park Avenue. That's the way you get to the airport there. I got so lost before. I was 10 stops by Park Avenue before I realized what they were talking about. Okay, no, that's not quite right. To keep this in scale, you'd probably have to be standing on the moon. Certainly in France, right, or in China. If this is 90, he's the nearest star. He's trillions of miles away. This is so, and the farther away you are, the less parallax there is, right? I mean, but he's right. If I had the three of them standing in the parking lot, and the three of, and he's going around her, they wouldn't appear to move. But this is a model. A model. Let's give them all a big hand. Thank you very much. Well done. Well done. See why I needed tall people and short people? I had to hide you. Okay? So let's go back to the PowerPoint. In fact, what we have here is a theory is an explanation of the facts. It attempts to explain why the world is the way it is. Let's take another vote. Gravity, fact or theory? Who votes fact? Who votes gravity's a fact? You vote gravity's a fact? Tell me your name. Maddie. Push it down.
Maddie.
Okay, Maddie, come up here and show me gravity. Put the camera where you want to. Okay, wait till the camera's on you. Come over here and stand next to me. Okay, can you get the camera on her? Okay, show me gravity. I saw a pen fall. Where's the gravity?
Well.
Wait. Where's the gravity?
I don't know. There is none.
Why did the pen fall?
I don't know. The force of
gravity. The force of gravity. There you go. Good for you. The gravity is the explanation for why it fell. Here, I'll show you gravity. Ready? Let's go back to the... What? Thank you. Give her a big hand. Good job. Let's go back. I'll show you gravity. Here, let's go back here. Let's go back to the tablet, to the overhead. Right? I believe this is right. It's m1 times m2 over the distance squared times a constant. This is equals gravity. Gravity is... You get the force of gravity by the mass of one times the mass of the other, divided by the distance squared times some constant that Newton figured out. That's gravity. It's a hypothetical mathematical construct that explains why it fell. Okay, so we have the mass of the pen, which is not too big, the mass of the Earth, which is enormous, times the distance between them squared, which is almost nothing. Maddie's standing on the ground when she dropped it, standing on the Earth, or Right, sir? Now, if I were to take that pen and put it out into space, the distance would get huge and would probably make it an orbit. It wouldn't fall down quite as fast, right? You understand what I'm saying? Move the moon a little as close as the pen, it'll crash into Earth and it'll be the end of all of us, right? Because the mass is huge. Gravity is, let's go back to here. Let's go back to the header. See? We have a small mass times a huge mass in very little distance, right? If you have two huge masses, like the Earth and the, compared to the pen, I don't know what huge is, the Earth and the moon, then even though the distance between them is far, there's still a gravitational attraction because they're, right? But it doesn't fall into it, fortunately for us, it just goes around. Okay? Good for us. Okay? So, gravity is a hypothetical construct to explain what Maddie showed us. The pens fall in the water, goes downhill, etc., etc. Okay? It explains why. Now, some explanations are so good we treat them as though they're facts. Atoms? No one's ever seen an atom. It's a hypothetical construct. Getting upset, aren't you, Mr. Physics teacher? Oh, I used to have a fight with a guy on the physics faculty here. We used to go at it. Atoms are a fact, he told me. So what are you talking about? You never saw one. So in the end, he finally said to me, okay, I agree with this, it's a theory, but it's one that'll never be overturned. So in the end, let's just get one more slide. Okay, we'll discuss this next time. What happens is that the data test our theories, and the theories explain the data. Theories have to explain the data, and when we get new data, we sometimes have to change the theory. That's what we'll start with next week. Okay, we'll see you then.